Today I'm going to show you how to bore an emergency collet in the machine for those situations where you're stuck between a rock and a hard place. Now let's jump over to the machine and search for clues, gang. So we're at the machine, which is the easiest place to bore an E-collet. We have a 3-jaw E-collet, count them 1, 2, 3, good. We have 3 pins that we're going to put in the face of the collet in these 3 holes that separate the jaws, and we're going to clamp on those to load the collet for boring. So if you get a 4-jaw collet, you're going to have 4 pins. If you get a 2-jaw collet, you're going to have 2 pins. If you have a 1-jaw collet, you don't need any pins. So we're going to get these out of the bag carefully. Try not to lose them. If you bore a few E-collets, save the pins because you will lose them. And you will need more. They will just into the abyssal beyond, and you'll have to go get another one. So we're going to put them in the holes. It's their hole. It was made for them. There we go. And then we're going to set our collet clamping on those pins. You can use the auto set if you do that. Just be aware that those pins might fall out while it's turning, so watch out for that. So we're just going to... Oh, perfect. It's almost like I set it up beforehand. Okay. We're in there. Our clamping's good, so we're going to touch off our end mill. We're going to use an end mill to drill the initial hole. And using an end mill over a drill for the rigidity. So we're just going to peck in with the bottom of the end mill like it's a drill, but we want the rigidity in the bottom cutting because we're going to have a real uneven interrupted cut, and the end mill is going to handle that better than a 2-flute drill. So we're going to touch off our end mill for the initial hole, and we're going to touch off the boring bar that we're going to use to embiggen the hole. And I'll show you how to do that in MDI. I'm going to do all this in MDI. You can take this, hopefully they'll get a nice tight shot of the screen, so you can grab what I put in MDI and you can put that in a program. I have a program. There's too many variables and looping subroutines, so we're gonna have to build up to that. That's for a future video. So for now, we're just gonna do it quick and dirty in MDI, and I'll show you how to do it, and you can take that and put it in a program if you want, but that's on you. I'm not responsible for anything that happens after that. So you should know how to touch off your tools. We did a video on that, people. We did a video. Watch the video. If you don't know how to touch off your tools, go watch the video. Jump over to the screen, tool 31, longitude, man set. I'm gonna go fast because you should know this. -2 inches for good luck, go. We shouldn't have to turn the interference check off because our tools are so long. We're gonna grab our paper. So we're gonna jog it up and touch it off with paper. Input, opposite retract. I'm going fast through this because you should already know how to do this. Tool 34 is our pH horn boring bar. And it's, that one's set up. We'll go -3 inches on that one. That one's set pretty close. And we're just touching them off the face of the collet. Good enough. Opposite retract. Go. Tools are touched off. It's time to go to MDI, and hopefully they get a nice tight screenshot so you can see what I'm doing. We're going to go to MDI and program a hole with tool 31 to drill a hole in our collet. So we jump over to the screen, to MDI, tool 31. Look at that, how convenient. So we're going to go M88. Interference check off, G98 inches per minute, just because you know exactly what's going to happen. Tool 31, M23, S2 equals 250. And then this is a live spindle. Careful not to cut myself open. It's a live spindle, so we're going to spin the end mill also. M180, S5 equals 250. So we're going to get the drill and the end mill counter rotating. They're going to go against each other, and that's just going to help the end mill drill a rounder hole. It's going to help it center itself and make a more consistent hole. Everybody likes consistent holes. Spindle's coming up. So now we go G0, Z minus 0.1. I'm not going to put a tool offset on this because we're just poking a hole. So remember, Z0 is the face of the collet, so we're going to wrap it up to Z minus 100 thou for our approach move, and then we're going to put in a peck. G83, Z25. Your Z depth has to be deep enough to break through the backside of the collet. Q, oops. Q.0202 F 2 inches. 53 W. Jeez. Need to clean these keypads out. All right. Peck cycle, Z 1 inches 250, 20 thou peck, 2 inches a minute. Full retract on the sub. Actually, I'm going to turn the coolant on here. Why not? M52. Turn the coolant on. Everybody needs lubrication for their consistent holes. W0, M25, M182. Turn the spindles off. That's it. That should be it. Should be all we need. Turn your feed down, make sure you're on all block, make sure you're on side 2. If you try and run this on side 1, it won't work. It'll tell you it'll tell you you can't call that tool number. So make sure you're on side 2. Input, feed down, cycle start. And we should be okay. There's not too much coolant going every which way. So G83 is running. You can see we're pecking. If you're watching see we're pecking. And it's just going to drill a hole 1 inch, 250 deep. I don't know if it's picking it up on the video, but it's grumbly from that interrupted cut, which is why we're using the end mill. But your best bet is just to go low and slow, about 600 RPM, 2 inches a minute with a 4 flute end mills. It's about right. We used to do this in manual. We would hand jog it in manual, so we'd jog it up. Yeah, it sounds like it's getting a bit loaded up. Back it off a little bit to clear the chips, jog it back in. So much easier this way. And again, you can grab that and just put it in a backside only program. You just have side 1 is G600 M2. Nothing happens on the front. And then just put that on the backside, put your G600 at the top, and then just grab this chunk of code and run it. And as long as you don't, hopefully you're not using the tool already in your program, but as long as you don't put offsets, an offset call on your tool, it won't pick up offsets. When we go to the boring bar, I will put an offset in there so that we can measure it and actually see what size we are. All right, we'll shut the coolant off. Put an M53 in there after the horses left the barn. Top retract, and then grab some convenient piece of crap. There is no convenient piece of shit. All right, just grab something and make sure your hole's broken all the way through the back of the collet. Yep, I don't feel a step. It's just breaking all the way through. The full length of the pad is bored through, or drilled through. Not really bored yet. So we got a hole. Now what? Well, we got to make it bigger. So your initial hole should be as close as possible within reason. 3/8 is a good size as long as your finish collet diameter is bigger than 3/8. So if you're trying to make a 254 diameter collet and you drill at 3/8, it gets a little bit more complicated. But 3/8 is a good number if you're making any collet size over 3/8. You want it as big as possible without going over your finished size. So 3/8, so we're gonna go back to MDI. Take this, look at it. pause the screen, take a screenshot, because it's all going away. We're gonna rewrite it for our boring. So we're gonna go tool 34. Tool 34. We're gonna bump this up to 650, sure. So your boring bar is a static tool. Only the sub spindle is gonna be rotating. So we gotta run it faster. 650 RPM, that's about right. 400 to 800, depending on the size you're doing. G50, U182, that's our work shift to the tip of our PH horn boring bar. 182, G0Z minus 0.1, X, actually. I like to have my X, Y, Z in order. 375. What's that gonna be? That's gonna be 425. 425. T34. There's our offset call. So we drilled it 375. We're gonna take the first boring pass at 425. We're gonna take a 50 thou bite, 25 thou step over. And that's about where I like to run that for these. These collets are moderately hard. They're not hard, but they are harder than not hard. So about a 25 thou step over. And then we're just gonna go G1Z 1.25 F 1 inch a minute. There, that's about good. G0 U incremental move to move off the ID, because you don't want to drag that tool nose back out the wall. And then G0Z minus 0.1, G50U. Cancel your work shifts. Always remember to cancel your work shifts, people. And then G53 Z0 and 25 and 53. So we'll stop the spindle, turn the coolant off, and then we'll take the first pass, and then we'll measure it, and then we'll start making offsets. So I'm gonna finish this collet at 666, the devil's dimension, because we do actually have a part that can use that. So we'll put that up as a little note, and then we're just going to every time we take a pass and want to step it out, we'll just come in here and change this X diameter. We'll just step it out 50 thou until we get to 666. All block input. Our interference check is off. Cycle start. I'll turn them over. We're going to turn on. And we'll get the coolant nozzles are a little bit floppy. They need a little bit of a pick-me-up. So you wouldn't believe how hard it is to get Viagra when you tell them you want to put it in your machine's coolant system to keep your nozzles from flopping, but we'll just let it go. We got one. That's all we need. Oh, it's pissing on the floor. There we go. Problem solved. Should have had a piece of cardboard on hands. But we're rolling. I don't know if you can hear it, but she started boring. We just took our first boring pass. Gonna measure with the calipers and make an offset with tool 34X so that the dimension we programmed is the dimension it is cutting. So we're just gonna stick the calipers in there, wiggle them around. I don't know if the GoPro can see that, but we're at 4095. We programmed 425 and we got 4095. So plus 15.5 in tool 34X. Offset 34X plus 15 and a half. Sold to the gentleman in the back. Back to MDI. We're gonna bump this out another 50 thou, 475. Close the door. Input, all block. Cycle start, and we'll turn the coolant on. Now we wait. We're gonna check this one again and make sure our offset's doing what we want it to. Yep, 475.5. I am good with that. That is close enough for the girls we go out with. And then you'll just keep bumping this up 50 thou at a time. 525. Input, coolant, cycle start. Well, we just finished our last rough boring pass. So we are at an X diameter 650, finish diameter 666. So we're gonna start slowing down our step overs. To account for tool pressure, we're gonna take a couple spring passes and then make sure we get a good clean, nice finish on our collet, because we don't want chowdery collet marks clamped into every single part we run. So we're gonna step down. Instead of going 50 thou steps, we're going to go 25. So we're at 650, we're gonna go, oh, that would be bad. We don't wanna go 675. We're finishing at 666. So we're at 650, let's go 660. Good. We'll take one more boring pass. This is a fairly time-consuming process. It's not something you just snap your fingers and it's done. So we're just taking a 12 and a half thou step over. Actually, we're not. We're taking a 5 thou step over. So we're gonna go, actually what I'm gonna do, I'm gonna run a spring pass. I'm not offsetting it out, I'm not moving it out, I'm just running a spring pass at the same dimension. We're gonna measure it again and see where we're at and make any final offsets we need to hit 666 exactly, or as close as my calipers can go. You can get, you can use gauge pins, you can get as fancy as you want. If it really matters, you can use gauge pins, you can get your plus and minus gauge pins and hit it exactly on the nose, but for the most part, calipers are gonna be good enough. It's a nice time to zone out and contemplate your life choices. Oh, break time's over. So we just took a spring pass. We're gonna blow some of the crap out of the collet. So we are actually, make sure we're actually measuring on the collet, not in the slot. We're actually coming out at 654. We blow it out a little bit better just to make sure. We're gonna have to pull all this out at the end and clean all the chips and swarf out of it anyway. 656. All right. So we should be 660. We should be 660. We're at 656. So we're gonna go back to our offsets. +4. My brain's not that fried. I can still do that math. Oops. Back to MDI. And we're just gonna go for it. Final dimension. One more pass, you got one more chance to watch a couple of YouTube shorts. And so with cutting an e-collet, you don't have to cut round holes. You can actually mill square holes like this one that's going back in there as soon as we're done shooting video, so I can actually run parts that make us money. Square collet. I milled it in there with the G12.1 that I showed you how to do in our G12.1 milling video. Posted out with Mastercam. So you can make square holes, you can make triangular holes, dodecahedronal holes, whatever a 12-sided thing is called. Whatever shape you need. Rectangular holes, oval holes. That's about all the kinds of holes there is. 666.5. We'll ignore that that rounding error and call it good. So we got to pull it out. We cut it. It's perfect. For the purposes of this video, it's perfect. It's packed full of just fine powdery sludge. So we have to pull it apart and clean all that crap out. They did not skimp on the magnets for our wrench holders. Wrenches, brass. Oh yeah, look at that. It's even all stuck together from all just that fine, sludgy, powdery chips. Delicious. That's what we're getting rid of. We're getting rid of all that super fine, gritty powder that works its way into everything. But that's it. There you go. There's how you bore any collet. All you have to do is take your pins out, save them. I'm gonna put those back in the bag. And then it's nice to go through with a Dremel and a soft bit and just break those corners a little bit. Break those corners, break in between the slots, wash all this gritty chips off, and you're good to go. Put it back in, verify your clamping pressure with a gauge pin or a part, and you're in business. So there you go, quick recap of the process. You put it in, you set it on those pins, drill, bore to size, and then the most important thing, when you take it out, mark it. Laser it, electro pencil it, mark what size it is so that you know what it is 6 months from now when you go to grab it, because any collet that's not marked is going to be recut and then marked. So hope you enjoyed that, hope it was helpful, and we'll see you in the next video.